We just witnessed what occurred about 30.8 billion years ago. Before that, there was no space, no time. Everything, all energy and mass, was concentrated in an extremely hot and dense point. But the Big Bang wasn't an explosion. It was the sudden expansion of space. In the very first tiny fraction of a second, the universe expanded extremely fast. This period is called cosmic inflation. Right after inflation, the universe was still very hot. In just a few seconds, particles like quarks and electrons appeared. Quarks quickly formed protons and neutrons, the building blocks of atoms. Within the first 3 minutes, these particles started to combine. Through nuclear fusion, the universe formed its first elements, mostly hydrogen, some helium, and a bit of lithium. This process is known as Big Bang nucleosynthesis. Heavier elements like carbon and oxygen didn't form yet. For years, the universe was too hot for atoms to hold together, but around 380,000 years after the Big Bang, things cooled enough for the electrons to join with nuclei, forming neutral atoms. Now, after cooling process, light could travel freely. That first light is still around us, and we call it the cosmic microwave background radiation, or CMB. It's like a picture of the moment universe was born. This light looks almost the same in every direction, but satellites like WMAP in 2001 and later Planck in 2009 discovered tiny temperature differences, and thanks to them, now we know the universe is about 30.8 billion years old, or it's made mostly of dark matter and dark energy.
That picture behind me is really, it's an image of the whole sky, and it's made to image the whole sky on this oval. And you can see in there blue spots and red spots. And what those correspond to are slightly hotter and colder images of the sky. That's a picture there, those hot and cold spots, that pattern is really it's the afterglow of the Big Bang.
Planck, launched in 2009 by Ariane 5, is the third mission to study the cosmic microwave background to date.
In constant rotation, Planck scans the entire sky. Planck is able to work back in time and show us the history of the universe from the first light ever produced. These fossil radiations resulting from the Big Bang occurred the cosmic background radiation. Over time, gravity pulled matter together into clumps. Those clumps became the first stars and galaxies. Heavier elements formed inside the stars, and those stars eventually exploded, leading to spreading those elements across space. This process repeated over billions of years. Eventually, planets formed, and one of them was our motherland, Earth. And the rest is history. So let's wrap it up. The hotspot began to expand, and in the first second, quarks and electrons came together to form protons and neutrons. During nucleosynthesis, light elements were made, and later, when the temperature dropped, the first light was emitted, and over the years, stars and galaxies were formed. Star explosions spread heavy elements throughout the galaxy, and gradually, planets and other celestial bodies were formed. But how did we get all this information? Who did it? It may be inconceivable that these discoveries were made before the existence of sophisticated modern technologies. For thousands of years, humanity have searched for answers, not only in stories, but in reality itself. We turned our eyes not just to explore space, but to uncover the truth.
5, 4, 3, 2, 1, and liftoff. Space Shuttle Discovery, taking the space station to full power for full science.
All came together to uncover what no eye had ever seen, and what we found changed everything.
Big Bang.
The Big Bang. The Big Bang.
You know about the Big Bang?
The Big Bang Theory.
Big Bang Theory.
No Big Bang.
Big Bang Theory is cartoon physics.
At the dawn of the 20th century, we believed the universe was eternal, still unchanging, a silent theater, where stars sparkled like fixed diamonds on a cosmic ceiling. But the universe had other plans, all thanks to one man, Albert Einstein. In 1915, Einstein introduced general relativity, a revolutionary theory. He showed that space and time weren't static. They could bend, stretch, even ripple under the weight of mass and energy. His equation whispered something shocking. The universe might not be standing still. It could be moving, changing. But Einstein didn't like that idea. So he added a patch, the cosmological constant, to keep the universe
I
static.
will either have tamed this beast, or will have been trampled by it.
In 1922, Alexander Friedman, a Russian physicist, solved Einstein's equation without that constant. His solutions revealed something incredible. The universe might be expanding or contracting. Then came a strange figure, a man wearing a priest's collar and a physicist's mind. Georges Lemaitre. Belgian, brilliant, and a Catholic priest. In 1927, Lemaitre quietly published a paper. He took Friedman's expanding universe and gave it a beginning. He said, all matter, all energy, all of space once compressed into a single dense point. He called it the primeval atom, the first cosmic spark, the birth of time and space and everything. This was the first version of what we now call the Big Bang Theory. And here is what's fascinating. He did it before Edwin Hubble's discoveries, using relativity and mass alone. At first, Einstein resisted Lemaitre's theory. He even told him, "Your physics is admirable, but your cosmology? Abominable." After Hubble observed galaxies racing away, confirming that the universe is expanding, Einstein changed his mind. He stood beside Lemaitre and said, This is the most beautiful and satisfactory explanation of creation I have ever heard. Ironically, the term Big Bang was coined as a joke on BBC by another physicist, Fred Hoyle, who actually disliked the theory. But the name stuck. Lemaitre never tried to make science serve religion. He once said, "There is no conflict between science and faith, but they must walk different paths." In the 1916s, when scientists discovered the cosmic microwave background radiation, a faint echo of the first fire, it was exactly what Lemaitre's theory predicted. He was old and near death, but he lived just long enough to hear the whispers of the universe proving him right. From Einstein's reluctant equations to Feynman's brave math to Lemaitre's silent vision, the story of the Big Bang is not just a tale of stars. It's a story of minds brave enough to imagine beyond imagination. And it all started with a quiet priest who saw the universe not as a steady painting, but as a growing, breathing symphony.